Papapodcasts presents Students Teaching Students. Today, we will be teaching about the concept of sine and cosine law, taught by Joshua from the grade 11 2014 class. Let's get started, shall we? The sine law is that A divided by sine A is equal to B divided by sine B is equal to C divided by sine C. Sine law is applicable to find the length or an angle of a triangle, permitting that if finding a side length, another side length, and two angles, one angle respective to the other side length, are known. But if you're finding an angle, another angle, and two side lengths, respective to the other angle, have to be known. So let's try this out. Let's say that A is 12 meters, A is 80 degrees, and B is 35 degrees. So in order to find B, you would have to cross multiply B with sine A and A with sine B. The product of B would therefore be sine B multiplied by A divided by sine A. That means B would be sine 35 times 12, which would be 6.88. Divide that by sine 80, which is 0.98, and you get your answer, 6.99. Or round that up to the nearest meter, and we get an answer of 7 meters. Now let's try this out with angles. Okay, so A is 30 meters, B is 10 meters, and A is 85 degrees. This is the same process as last time. The product of sine B would be sine A multiplied by B divided by A. Therefore, sine B would be sine 85 multiplied by 10, which is 9.96. Divide that by 30, we get 0.33. Now, this is the result for sine B, and we're looking for B. So let's take the number we just got and find the inverse sign. Therefore, B is 19.39 degrees, or just 19, rounded to the nearest degree. Now the cosine law is that A squared is equal to B squared plus C squared minus the product of 2, B, C, and the cosine of A. Cosine laws can be used to find the length or an angle of a triangle, permitting that when finding a side length, two side lengths and the respective angle of the missing side length are known, and when finding an angle, however, every side length must be known. So here's one example of cosine law. B is 4 meters, C is 10 meters, and A is 110 degrees. We are trying to find A. The product of A squared, therefore, would be 143.36. Square root this number, and we have our final answer for A, 11.97 meters, or rounded off to 12 meters. And here's an example to find angles through cosine law. As you can see, we have all the side lengths given. A is 5 centimeters, B is 10 centimeters, and C is 12 centimeters. Following the equation, the product of negative 2, 10, 12, and the cosine of A would be equal to negative 219. Divide that by the product of the known values on the other side of the equation, and we have 0.9125. Again, this is the result of the cosine of the angle. So we invert cosine our value so far, and we get 24.15, and round it down to 24 degrees. Now regarding three-dimensional figures, sine and cosine law actually work just about the same regardless of if a figure is 2D or 3D. Naturally, if you were to find a certain side and there isn't enough information given with one side, you could use the other to find more side lengths as needed. Of course, sine and cosine law aren't always necessary, because while they are most of the time, if one face happens to be a right-angled triangle, Pythagorean's theory could be used instead. We're trying to figure out the value of x. The face with x has two known angles of 63 and 27 and one side n, which connects it to another face. This other face has a known angle of 70 respective to n, as well as two sides of 27 centimeters. Naturally, we would have to find n first, using cosine law. It is the same procedure as the last example slide. With the known side and angles, n squared is equal to 959.3. Again, this is squared, so find the square root, which is 30.9. And with our known side, we can use sine law to find x. The product of x would be 30.9 divided by sine 27, because while x normally would be multiplied by sine 90 is equal to 1, so it wouldn't make any difference. Our answer for x is 68.2 meters. And finally, here's an example of a three-dimensional figure that can be solved with both sine law and Pythagorean's theorem. The value we want is n. We have a given hypotenuse of 50 meters, and B connects this face to another. This other face has two known angles of 70 and 26 and a given side length of 50. First order of business is to find the one unidentified angle, theta. We subtract the sum of the other angles. That's pretty straightforward. We will use this to find B through sine law. The product of b would be 15 multiplied by sine 26 divided by sine 84. Our product here is 22.04 meters. And with this information, we can finally find n. With 50 as the hypotenuse, we will subtract the square of 22.04 from the square of 50 to find the square of n, 2014.27 meters. Take the square root of that number, and we have 44.88, the side length of n. And that concludes this lesson. Thank you for watching. I hope you all have a wonderful day, and I really hope this was informative.